All right, hi everybody. Welcome to Philly CodeCamp, virtual edition. And I wish I could be in person with you all, but the global powers that be really prevent that. So maybe next year we can all get together. So I have the chat up. If you have any questions, I'm not always going to have the chat up. I'm going to flip over every couple minutes or so. So if you have questions, put them in the chat. I will jump over periodically and then scroll back. All right, well, let's begin with some introductions. Hi, my name's Kevin. I am so glad you're here. And there we go. My keyboard's not working. If you've never met me before, hi. And if you've never seen me present, well, I would like to say you're in for a treat, but you're probably not. They're like way better speakers than I am. But I'm Microsoft MVP. I've been the MVP for a while. I love talking about ASP.NET Core, Microsoft Azure, and just in general building web applications on the modern web. If you'd like to talk to me, Bill, I think your mic is open. If you'd like to reach out to me afterwards, consultwithgriff.com is where I live on the internet. I'm also very active on Twitter, and I do a somewhat regular Twitch stream at twitch.tv/onekevgriff. I also have some big news, and that's why I'm really excited to hang out here with you today. It's not an Azure course, but it's actually a course on Signal R. So if you're in the ASP.NET Core space or you're developing anything in .NET, so whether it's .NET Core or if it's .NET 5, I just released a new course called Signal R Mastery that will teach you how to become a master in building real-time web apps. And it's actually on sale right now on Udemy if you go to signalrmastery.com. But we're not here to talk about Signal R. I wish we were, but we're not. I'm inviting you into my shed quarters, my office in the backyard, to talk about logic apps in Azure Functions and kind of the unique ways that I think developers can take advantage of using them. All the sliding content for this particular session is available on my website. I know everyone asks this question afterwards. Hey, can I get your slides? Hey, can I get any code samples that you might have? I actually haven't checked this page in a while, but if you go to 21st, consultwithgriff.com/21st century, all the details should be up there. So let's begin with the discussion of background services and what kind of that means in the grand scheme of things. Here's just a basic, box cylinder layout of your average web application living on the internet. And I would say a very good percentage of web apps look something like this. You have people out on the internet, they connect to your web application, where your web application is hosted in Azure, hopefully, or it could be on AWS, it could be on Rackspace, it could be in a variety of places. And they probably talk to a database of some sort, whether that's SQL Server, if it's Redis cache, if it's some sort of GraphQL database, or there's a variety of places that data can live. And then hopefully you have this other box for background services, because there are some things that your web app should just not handle on its own. Well, Kevin, what do we mean by that? Well, for example, sending email. If you have a request handler in your web app that is supposed to trigger email getting sent, your web app should not be sending email within that line. Let's think of it more this way. If I'm on the web app and I click a button on the page that says send email, sends a request to my server should just go, okay, we got the request, Kevin, 200, okay, everything's good. What it shouldn't do is attempt to send the email and then send the response. So sending email is one of these things that we should marshal off to a background process. If you handle payments, your web app should not handle the payment processing immediately. It should accept the request, it should send back a response to the server or to the client, and it should take care of the payment processing later. If you've ever used Amazon, I mean, everyone's used Amazon, right? You click buy now and you confirm your payment details, and what does it give you? it doesn't give you payment success. It gives you order confirmation. And order confirmation just means we got your order, but we haven't charged it yet. We haven't even checked to see if all the inventory is there that we're expecting it to be. And we definitely haven't shipped anything. But we're confirming that we got your order. Background services will kick in later to go through and do all that other stuff. And it's a lot more complicated than what I'm explaining, but that's generally the web app should not be doing that. You might have use cases where you need to clean up your database or your file system. I put that there because that's specifically an issue I've run into numerous times where I've accidentally put gigabytes, if not close to a terabyte of data into something like Azure Blob Storage. And it's just not necessary. And I had to go back and clean it. So we have background services that clean up after ourselves. But generally, anything that's a reoccurring task, if you need to run a report every hour or every day or every week, that's not something that your web app is naturally going to do. It needs to be something that's reserved for a background service. And I probably could keep going on with different examples, but hopefully you're getting the gist of it. Well, how would you do that in a normal .NET Core application today? Well, there's a variety of ways. One of my favorites is a system called HangFire. If you've never used HangFire before, do yourself a favor, spend like 15 minutes looking it up. And it's basically background processing in .NET, where you can you connect HangFire to some sort of background database like SQL Server, or if you're paying money, you can connect it to Redis or other backplanes. But in your code, so if I said send email, my server can say, well, I'm going to add a task to send email with this data later. And HangFire is going to sit there and churn. And as it's available to process these jobs, it's going to process them in the order that they're requested. And it has automatic requests retry. So if something fails, it'll retry automatically after a couple of seconds or a couple of minutes. If it fails completely, it'll notify you of all that stuff. And you can get this really good graphical look of your background tasks being queued, being processed, and then having successfully or not successfully occurring. This works really well. I have a couple little qualms with HangFire, but I've used HangFire successfully in numerous clients' applications. Most recently, and I say most recently as in the past, 2 years, we've been introduced to hosted services inside of ASP.NET Core. This is the idea that you can have your main ASP.NET Core process running, and then there's a background service that can run automatically and just maybe check a queue every minute and process stuff that's coming through. I actually took a client application and we were using HangFire to process incoming requests. I refactored all that code to use background services, and I improved the performance of that app, like I would say tenfold, but like 100-fold, because where HangFire might have a second or two of delay or latency, the background services in ASP.NET Core, we're talking milliseconds. Like as soon as I added something to a queue to get done, it was done. So in general, this is my picture of HangFire. It's one of my qualms with HangFire is if you want HangFire to be super performant, it needs to be a resource hog. And we had a server that we were running HangFire on where this was the case. It was 100% CPU, and we're using a good amount of memory. What we ended up doing is having to re-architect where we host HangFire versus where we host our web applications. So HangFire wasn't smothering our web apps. The other way of doing it is we could tell HangFire, well, don't check the queue every second. Check the queue every 5-10 seconds. And that would dramatically lower the CPU. But then you're not being very performant, right? Over the past, I would say year and a half, I've been looking for alternatives because I'm really interested in background services and finding things that are easy to maintain and easy to create. I have a variety of clients that just throw me these little oddball tasks, and they say, we need a service that does X, Y, and Z. And I like to find things where I don't necessarily need to write code. I could just design a workflow, write code if I need to, but just the design of workflow of it is one thing and does one thing really well. And I've had numerous people say, you should take a look at Logic Apps. And I did. So Azure Logic Apps is my new de facto standard for any time someone asks me to build a background service. And the easiest way to explain what it is it's like Zapier or Zapier, however you pronounce it, or if this then that for developers. If you've used either of those services, they are task oriented, they're low or no code, and you're generally just designing a workflow. And they all kind of work in the same way. You start with the trigger. So a trigger being a recurrence, a schedule. So every minute, every 10 minutes, every hour, every day, every Thursday, whenever this schedule happens, it triggers a logic app that occurs. It might also be a webhook. So if you're a developer, you're probably familiar with webhooks. A request comes in from another service saying something happened. It might have a small payload, and it goes off and it does some work. But then others where it starts to get fun. Other might be you get a new email in either your G Suite or Outlook email account or your Office 365 account. It might be someone added a new issue to GitHub. That could be a trigger. So there's a lot of surface area for what a trigger could possibly be. Once the triggers occurred, you start going into actions. So an action might be, well, let's go pull data from a database, or let's go execute an Azure function, or let's go ask this other service for some information. And you just keep adding these on top of each other. So action leads to another action that leads to another action. And it can get even smarter than that. We can branch off and have conditions. Say, well, if the response from SQL Server was true, let's do something. If it was false, let's do something else. And we could go down the line for every trigger, there's probably 10 different actions that could occur within a space. And we're going to dive into a real example so you can see all this in action. Ha, no pun intended. What I also love about Logic Apps is that it's all consumption-based pricing. And for a lot of my clients, price, just their cost is a concern. And when you're in the cloud, you know it is easy to just accidentally rack up $1 million in billable. I mean, I'm being facetious, but I've had numerous cases where something like Cosmos DB, it's like, oops, I accidentally spent $1,300. And I use the accidentally like very literally. We set up the service, we used it for what we thought was a small use case, ended up racking up $1,300 of billable. Now, all that is 100% on me, not paying attention to like little details, but it happens. So consumption-based pricing is great because the alternative to this was I was running my own app service that was running background jobs, and it was just sitting there in this constant just cycle of waiting for things to occur, like timers or other tasks to come in. And when you do that, you pay for those cycles, regardless if you're using them or not. With consumption-based pricing, with Logic Apps or Azure Functions, you just pay for the time that your app is actually doing anything. Of tasks that have occurred, and look, the longest one is 4 seconds. That cost me like a fraction of a cent to run that particular method. So at the end of the month, this app might cost all of 30 cents to run for a period of time. So it works out really well. But I want to dive into an example and show you around, answer any questions that you might have, or at least spark your imagination. So I have already taken the benefit of creating an Azure, resource group. This is where we're going to do our work. And I'm going to, and I'll zoom in as necessary. So I'm going to go ahead and create a new Logic app in the Azure Marketplace. So they have this new one for Logic App Preview. I'm not going to show that because I have not spent enough time with it to show it realistically. So we'll just do it the old way. So Logic App will say create. Now it's going to ask you just for some simple names. Each logic app stands separately, so you have to make sure you give your logic name a unique name. So we'll say logic app name. We'll say Philly CodeCamp logic app. I'm going to put in East US. You can also set up integration service environments if you're going to have a lot of them and you want to try to narrow down your billing. I have a couple use cases where I should be doing that and I'm not, but we're not going to worry about it here. You can also enable log analytics if you want to monitor the workflows coming through, but that's not necessary in a lot of cases as well. I'm going to say review and create. Yep, not much to it. We'll say create. This should only take a moment to initialize. We'll go to our resource. And this brings you up to, I'm going to zoom. The Azure Portal does not like zooming a lot. So this is going to come up with the Azure Logic Apps Designer, which is really good if you're just getting started. You can watch the video that explains, probably in a little bit better detail than I am, how logic apps work in theory. You can also walk down and select a trigger. So if you want to set up a trigger when a new file is added to OneDrive, or when a HTTP request comes in, this is the one I use most commonly. You also have recipes. So if you've used if this and that or Zapier, you know they have recipes. Okay, well there's a recipe for when X happens, do Y, and so on. They've created a couple of these for you. Let's scroll down. When a new file is created in Dropbox, copy it to OneDrive. Yeah, that's a thing you could do. Email yourself tweets about a certain keyword via Outlook. Super interesting. Share my tweets on Facebook. Now, these aren't business-oriented tasks, but they could be. And this is just showing you the surface. If you have a variety of business-related tasks that you need to design out, there's workflows in here for that stuff. If you approve a new file in SharePoint, move it to a different folder. That seems like a very business-oriented task. Well, let's scroll up. I'm not interested in business-oriented tasks today. I want to show you something fun. Hopefully, we can get everyone here involved. So we're going to say when a new tweet is posted, we're going to pull in the Twitter connector. So I'm going to add Twitter. So this should, it locked up on me. Jeez. So it is supposed to. All right, well, let's restart this. It's supposed to come up and authenticate my Twitter ID. Sign in. Let's see. We'll call this Twitter. It's going to sign in. Yep. All right. So it's going to ask me for my Twitter credentials, which I have in LastPass. So this creates what's called it's called a resource or endpoint. So now this resource for my Twitter account is reusable. If I have multiple logic apps that all need to connect to Twitter for some reason, they can all use this one authentication. And all the authentication details are hidden behind it. So if we need to change the authentication for our Twitter account, which happens sometimes, like the password changes on a Twitter account, well, now I don't have to go back and fix 15 logic apps that use this one Twitter account. I just changed the one Twitter access, and now all of a sudden all the other apps work. So I'm connected to Twitter. We'll say continue. And the designer is going to ask me a couple questions about this specific trigger, like search text. Well, I'm going to just type in my username, OneKevGriff, on Twitter. If you're not following me, give me a follow. We're going to check for new items we're going to say not every second. We don't want to do every second. We'll say every 30 seconds. I think that's a good number. And this is the most common parameter, but there are also additional parameters we can add. And I'm going to zoom in on these. Oops. So I could say, well, I need to control when this starts. So don't start this workflow until tomorrow or until the end of the month. If I need to control the time zone, I could do that as well. This isn't a good use case for time zone or start time. But we'll say every 30 seconds, go check Twitter for new search items on my username. So this is the trigger. Then we need to create a step or an action. And all right, here's our action. We have a variety of things we can choose from. Now, Logic Apps is going to try to figure some of this stuff out for you, or it's going to give you recommendations based off your usage of Logic Apps. You could go click all at any time, and you get what I call it's the catalog of options available to you. So I hit this little down arrow. This is every application that has support inside of Azure Logic Apps. So if we scroll down, let's see, Discuss. There's DocuSign, so if you need document signature and you need to integrate that into a workflow. If you're using Dynamics, if you use GoToWebinar or any of that stuff. Google Task, oh, we'll come back to that in a minute. That's interesting. So Google Sheets, Infusionsoft, the sky's the limit in here. You can do a lot of work with Logic App because there are connectors already built for all this stuff. Well, let's do one that's fun. I want to run that tweet through Cognitive Services. Now, if I spell cognitive right, so we'll do, it's actually text analytics. And I want to detect the sentiment of a tweet that just came in. So this is going to ask me for some account information, which thankfully I have already done beforehand because it takes a moment to allocate. So give me a second. Let me go pull that data. Philly. Let's go get our keys. So we'll copy a key here. So account key. We'll go get the server. And then we'll just call this Cog Services. All right, nope, we don't need to save that password. So notice it comes up with kind of a blank page. If I say add new parameter, it's going to ask me, well, what documents do I want to do sentiment analysis on? And this drops you into a little bit more refined editor. So notice this, this technically is going to be an array or a list of documents. I'm only going to use one of them, but it's going to be a list. And I need to find a unique document ID and also the text that I want to analyze. I also have to specify the language, but we'll assume English. Document ID. Well, I clicked on the box and something interesting happened. Over on the right side of the screen, you see this little pop-up that's going to ask me do I want to insert anything that Logic Apps already knows. So Logic App is looking at everything that's occurred before this action and is pulling the metadata out of it to figure out, oh, well, I can give you the tweet text. I can tell you who tweeted a specific tweet. I can tell you the name of the person. I can tell you their location, their username, their tweet ID. Ooh, why don't we just use tweet ID as the ID for Cognitive Services? That's a great idea. We'll say tweet ID. You can see it fills in the blank. Then we'll say document text. Well, we already know that. That's tweet text. All right. Well, so that's all good. I'm going to hit next step. And for next step, we're going to assume that Cognitive Services works successfully. And what do I want to do with that tweet now? Well, I think I want to put that into a spreadsheet. So let's look at my Google Drive real fast. I have a spreadsheet in here already. Here we go. So I have a spreadsheet called just Tweet Checker. And I have 3 pieces of information in here. The tweet text, who tweeted it, and what was the score of the tweet, so the Cognitive Services score. I'm going to ask Logic Apps to connect to Google Sheets. I can just type in the box of search and it should pop up here in a moment. You see Google Drive and then Google Sheets. I'll say Google Sheets, and I want to add a row or insert a row to Google Sheets. Now I have to connect to my Google Sheets account, so I'll do that real fast off screen. And this is going to create another connector. So this is a connector for Google Sheets in particular. So if I ever need to change this account, it can happen. And this takes a second because authorizing against Google just apparently takes forever in Logic apps. So we'll just sit here and wait a minute. And if you have questions, don't hesitate to drop them in the chat. Okay, so it's going to ask me for which file do I want to add the row to. So I hit this little box, and it gives me, it knows what's inside of my Google Drive because it's because I connected to it, and these connectors are smart. There's written specifically for the connector that they're working against. So if I scroll down, I have one here called Tweet Checker, and it's automatically going to fill in the blank here. Then it's going to ask me, well, what worksheet in Tweet Checker do you want to add a row to? And I'll say sheet. It's going to go read the sheet, and it knows that sheet has 3 columns: tweet text, tweet by, and score. Well, let's say tweet text. Well, this needs to be the tweet text from the original request coming in. Tweet by is going to be the tweeted by message from the original request. And then score. Now, score isn't going to come from the tweet. It's going to come from cognitive services. So let's look down here at detect sentiment. Well, there's just ID. That's not what I want. Well, there's more context available. There's a little button here that says see more. If I open that, here's all the metadata that comes back from cognitive services. You see the item itself. There's the score between 0 and 1, some sort of fraction, or the original documents. So we'll say score. Now, Logic Apps is being a little bit smart right now. It figured out that because the documents going into cognitive services is an array of documents, even though we're using one, it is returning an array of documents. Well, you can't just insert from, and it's going to tell me, hey, we figured out based off the output of cognitive services and what you're using, that this really should be wrapped in some sort of for loop or for each loop. So it inserted my element into a for each loop. It's going to iterate through all the documents, which will only ever be one, and it's going to pull the score out. So let me also zoom in here. So there's an underlying language for how these are stored in Logic Apps. So if I go in here, you can see items, for each, pull the score attribute off of it. Well, I could actually rewrite this and tell it, well, always assume the first element from items. I'm not going to do that just for sake of demo gods, but we'll leave it the way it is. But any of these, you could go through and you can write your own expression. So I could say, well, I want items for each. I want the first element, and I want score. So you can write that out. This is a little bit more advanced than what I wanted to show you today, but it really goes to show that Logic Apps is really flexible if you want it to be. So we're not going to do that. Okay, well, you know what? I think we're good. Let's go ahead and save this. It's saved successfully. I'm going to hit run. And now I need someone out there to go send me a tweet or mention me in a tweet. Remember, my Twitter ID is @1kevgriff. So I'm Twitter @1kevgriff. And I'm going to send my own message as well. All right, so I just sent my own tweet. So you can see right here, it's coming in. It's at the very top. And as we as we wait, this is going to check every 30 seconds. So hopefully, here in a moment, you can kind of see it waiting up here, the notification box. Hey, we have a winner. Something happened. This is the debug view of logic apps. Whenever a logic app executes, you can see every step of the process, including how long it took, whether it was successful, a failure, or if it was canceled, or it was skipped altogether. And you can walk through these every step of the way. So what was the input? The input was a search text for OneKevGriff. We had output from Twitter, which was me. All right. Well, hello world. I'm testing logic apps, and I'm at OneKevGriff. So my name satisfied the condition. And here's all the metadata for that tweet, if you wanted to know. Well, all right. Well, let's scroll down. Remember we took the text of the tweet and we passed it into cognitive services, saying, "Hello world, I'm testing logic app." This got back a score of 0.958, so like 86% positive. Yeah, that's good. We took that and we had iterated over it to add it to the spreadsheet. So here we go. Kevin Griffin, good to go. So if I come back to my spreadsheet, yes. Let's take a look here. Oops. Let me zoom in. You can see there's my tweet text. It was tweeted by me. I had a score of 96%. And then logic apps will add this identifier to the end of the columns, just so it can keep track of what's going on. You can always go back and add additional columns. You just need to make sure you keep this column in there for logic apps, because this is how it keeps track of where it last inserted something. So that's really cool. That's an end-to-end logic app. And at any time, you can come in, you can look at the history of the logic apps working, which it was just me. I'm sorry, folks. No one sent me a tweet. I wish you did. I mean, a little bit of participation goes a long way, but it worked for me, so that's fine. But I hope that's a good just example of logic apps in action. I actually have more to talk about, so let's jump back. Actually, let's look at chat. Any questions? No, you're all being quiet today. That's fine. No big deal. All right, let me jump back into slides. All right, so we did our demo. We toured the logic apps editor. Then we showed off the expression editor, and these slides are mostly for the case where I don't have internet. But we have the expression editor, which you can designate both dynamic or dynamic content, or you can create your own expressions. Logic Apps has a full language built into it. So if you want to do time manipulation or string manipulation or do math, you could do that with Logic Apps. It's all built into the expression editor. When you're going through, we don't have an example of this that we just showed, but if you run into errors, it's going to tell you what your errors are. And you can also set up retry policies for a lot of the actions in Logic Apps. So here was an example where I wanted to execute an Azure function, and that Azure function didn't work. Maybe it had an error, maybe there was a glitch in the matrix, I don't know. But I could set up a retry policy for that particular action to tell it, well, retry again 4 times, that's the default. Or I could tell it, well, retry 3 seconds later, 10 seconds later, 40 seconds later, so on. Or I could tell it, well, exponentially try longer and longer. So try 1 second, then 2 seconds, then 4 seconds, and then 8 seconds, and so on. Or you could tell it, well, just retry once and fail if it doesn't work. So there's a lot of ways for you to manage issues with your dependencies, because this is the #1 reason I would venture why a lot of background services fail, and probably why you should be using background services to begin with. It's not you, it's them, it's your dependencies. It's never typically an issue with my code. It's when I go to talk to the database. It's when I go to talk to Stripe to process a payment. It's when I go to Redis cache, something happens. And even though it might happen 0.05% of the time, you still need to handle these cases when stuff doesn't work and you want to potentially retry. What I like to do now is actually dive into a little bit more detailed scenarios of what I've used logic apps for and talk through some of the issues that I had. Number one is processing incoming email. So I had a client that said, Kevin, we want to watch an email account, and when we get a very specific email from a person, we want to take the Excel document that's attached to it and put that data into our database. I'm like, okay. I had just started working with Azure Logic Apps, and I'm like, well, let me see if I can code this up. Turns out there was a Gmail connector that I connected it and authenticated it against that particular Gmail account and told it, all right, well, the trigger is when an email comes in, we want to go get the email details. Oops, here it is. When an email arrives with a specific subject name, and how often do I want to check? Well, we checked every 15 minutes. I would go get the details of that email, including its attachments, come back. I can set some variables. So if you have things that can possibly change in the future, or you have variables that you want to set and then manipulate later, you can set those. So I had one because we had a weird like magic string for the name of the worksheet inside of this Excel document. So I'm like, let me put that in a variable in case it changes later. So it's in a variable, and then we go get all the attachments from the email. Well, an attachment might not just be the Excel document that I care about. It might be images attached to the email. It could be a variety of things. So what we do is we for each over all the attachments that we could potentially have. And for each attachment, I have a condition where I check to see if the attachment's file name contains XLSX, which is the extension for Excel documents. Well, if that's true, then I have this branch that will go through and process the worksheet. And if it's false, I don't do anything at all. We just continue looping. Well, that if true is really cool. We use a service called Convert to JSON that takes the Excel documents that we're pulling from Gmail or G Suite, and we're opening a specific worksheet on it. We're taking all that data, all the rows, all the columns, and I'm converting them to JSON because I can work better in JSON than I can the native Excel format. So this returns a JSON object that contains a list of rows. Well, then for the rows, I want to go through and I want to do more additional logic. So I'm basically checking to see, all right, well, let's go through all the rows. If it's the first row, which is the header row, right? I just want to ignore that. So we have a thing in here to ignore the first row. And then we're like, all right, well, if it's not the first row, or anything that's not the first row, let's go through and do some processing. Well, I ran into this problem where the dates that were in the JSON object are not a standard datetime format. And I forgot how Excel stores their datetime formats, but it's some weird calculation where you basically you have an arbitrary date and you add like seconds to it. I don't remember what it is. I spent at least a half an hour looking this up. But there was nothing native in Logic Apps at the time where I could compute the date time based off this number. And I said, well, I have a problem. I need to write something that does this. And it turns out I could write an Azure function to achieve this result without me knocking my head against Logic Apps or just writing everything as code. So I built an Azure function to do this work for me. I would pass in the value I had in the JSON, and it would spit back a datetime value that is more readable by Logic Apps. Well, we would take that value and we'd go to SQL Server, and SQL Server I could tell, well, insert a row into the database. I would tell it which server, which database, which table in the database. It would automatically look up all the columns in that table. It knew which ones were not null. Notice how they're required. And it would also show me all the optional or nullable columns. And I can go through and just fill in the blanks with the data that I have. And this worked so well because I just filled in all the blanks. This maybe 20, 30 minutes of effort, and it was working flawlessly. If I had to write this in code, oh my gosh, I'd spend a half an hour just remembering how to write an SMTP, a POP connector, so I could connect to Gmail POP email to get the email list and then process all the stuff. Yeah, I don't have that kind of time. Logic apps just let me build it. And that's why I'm going back to earlier, is that there are hundreds of connectors for external services, and they're all reusable. If you need to authenticate to GitHub, you authenticate once and reuse it across all your logic apps that need to connect to GitHub. And if for some weird reason you don't have a connector in here that you're expecting, you can write your own. And all these connectors have a variety of triggers and actions. The trigger might be, well, on this or on that, something happens. But then the actions might be, well, let's go do this or do that or do something else. The fallback is an Azure function, and it had numerous times with low or no code scenarios. I have always said this would be perfect if I could write a line of code, because I know how to do this in code. I don't know how to do this in the framework of the no code solution. And Azure Functions scratches that itch. If I could write a line of code, I could fall back to an Azure function. So that's what I had done previously. I had written a function to convert the Excel date value to a date function. And so I had to write a little bit of cleanup code, just making sure all my things were right. But really, it's just the last two lines of this function that I care about. And because it's an Azure function and it's in the Azure ecosystem, Logic Apps knows how to work with this function natively already, and it will fill in all the blanks and it'll pull back the example. There's also, and I wish I had a slide for it, I've been experimenting with Azure durable functions, which are more long-lived, and the native support already exists for that, where I could kick off a 5-10 minute durable function that might take time to process over a data set, and Logic Apps is going to handle it without any issues, and then pass back the results in exactly the way that I would expect it to. So I love Logic Apps. So let's talk about another scenario, which is very common in a lot of situations. Why is my... I don't know why my taskbar won't go away. Go away, taskbar. Yeah. There we go. Webhook processing. So if you're working with any system out there, you might have the ability to send webhooks down to your services when certain things happen. We use a service called, well, not a service, we use an app called Discourse for some forms and community management. And they have full support for webhooks built into it. And we use those webhooks heavily. Whenever something happens on their system, we have a webhook that executes one of our Azure functions. We have a JSON schema for what that webhook's data is going to look like. And we can tell, well, when this webhook comes in, this is what the data looks like. This gives us IntelliSense over the webhook incoming data. And I can go through and do a whole bunch of processing. So this is Discourse. I'm telling it, well, when the, what was I writing? Oh, I wanted to know when someone updated a very specific post in the forums. So we would say, all right, well, it's slug, the slug, what's the URL for that particular post? What's the ID of the post or of the topic that it's inside of? So I have all these variables in a single place, because we actually ended up copying and pasting this 3 or 4 times because clients have really weird requests. So we just copy and paste and we filled in the blanks. And what we would do is we would check that incoming JSON and say, well, does the data coming in match the data that I'm looking for? And it's all right, it's just a big if statement. If this and this and this, well, then we'll move on to the true statement, which is just simply updating a row in the database where we wanted to go to a place in the database that we store the last time this post has been updated. We would increment the value or change the date on this row, and Azure Logic Apps would do that for us. And then we did our own webhook to an additional service that would go notify everyone that the post had been updated. So Logic Apps made this super simple. The one part I haven't really talked too much about is I've shown the designer for all this, and I love the designer, works really well. But then there's a couple use cases where you just need to go in and edit some of the markup. So everything in the designer flows into this JSON schema. And I have not spent a good amount of time looking at how this JSON schema is supposed to work. There's rhyme and reason to it. I'm just not totally hip on it. But you could come in here, you could change names, you can make alterations, you can copy and paste blocks of code. What we'll do for just some sort of source control on our Logic apps is when we've made changes, we make copies of this and we store this in source control, because this is something that you can control in source control. But you don't necessarily have to do that. Logic apps will maintain an entire history of every change you've made to your Logic app, which I didn't really show, but I could show now. So if I'm in here, I could say versions. And on versions, this shows me every version of my Logic app that I've created, and I can go back and forth between them. And you can also say, well, this is the old version, but this is the version I want to promote and use in production. I've actually only done that like 3 or 4 times. It's not often, but it's there if you need it. All right. Oh, I see some questions in here. Do we need to publish or schedule the app to run automatically? When you hit save, it automatically starts. The trigger is active. So if there is something that happens automatically to run the trigger, it will start occurring. There is a disable button that you can disable. So if you don't want the Logic app to run, disable it so it doesn't run anymore. But if you have like a schedule or some sort of webhook, that's going to start firing immediately once you hit save the first time. Normally what I'll do is I'll set up the trigger and then I'll come back and disable it until I'm done working, and then we'll move forward. In real world, how can we compare performance of HangFire background services with Logic app? I think that's a good question. I don't think I have a good answer for it. I think it comes down to how process heavy your application is. I boil a lot of it down to the cost of running the Logic app. It's the cost of running a Logic app. It's the cost of writing a Logic app versus the cost of running and writing the code to do it in your own background service. For the majority of my Logic apps, they run at most 30-40 cents a month to run. And the time to develop them was drastically less than having to write and maintain the code. Whereas when I was running them in HangFire, we actually had to have a dedicated server that was running just HangFire services, and that has a cost associated with it. Eventually, if I just build on enough Logic apps, I will hit a point, right, where it costs more to run all the Logic apps together, consumption-wise, than it does to run the app service that I was running the apps on. I have not hit that point, like, at all, and I have a couple compute-intensive applications. One of the things I've noticed in Logic apps is where I do a lot of process-intensive stuff. So my most expensive Logic app costs $15 a month to run, which is a lot. Like, it's a lot because it runs often and it does a lot of work when it runs. If I was running that I've actually thought about converting that into an Azure durable function instead, because it would A, run faster, and B, I think it would cost less because it would run faster, quicker. That's kind of the hard part with consumption-based pricing is it's based off how much work you do. But I have a lot of logic apps where the work they do is just sitting there and waiting, but you're not being charged for that. You're being charged just for compute. So that is a very long-winded way to say it is hard to answer that particular question. But that's a really good question. And I still think I'm still working on a client right now where we're converting their HangFire background tasks to logic apps. And it's actually going to be a combination of logic apps and 1 or 2 ASP.NET Core background services or hosted services. Because there are some things that are just very compute intensive that need to happen in the background that I don't necessarily want to pull into a logic app. And there's also some workflows that are just too complicated for logic apps. If your logic app is trigger, action, action, branch, action, action, branch, action, action, branch, action, action, and branch, you might as well just write the code for it, because trying to go back and decipher in the editor what's happening condition-wise is a little bit more difficult. You could also create multiple logic apps. So if you have action, action, branch, action, 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 and so on, well, take one of those and make it its own logic app. I've done that, and that works really well. It's the same theory as why you shouldn't have say a C# function that does more than one thing. If you find your functions getting too long, break it up into other little or smaller functions. You do the same thing in logic apps, create smaller logic apps. So not sure if that answers your question. It's a very long-winded answer, but let's see. Well, I'm getting right here at time. Let me show you one more quick example, because this is the one where this was my first logic app. I had a scenario with my clients where we were putting stuff into Blob Storage, and I wrote the feature. Like, all right, let's put the data into Blob Storage. And I wasn't going to worry about cleanup because it was Blob Storage. So it was insanely cheap to begin with, because we were only putting a couple kilobytes of data in it on a regular basis. Well, turns out kilobytes add up to megabytes and eventually add up to gigabytes, close to a terabyte over a period of time. Now, I went back and I was looking at our spends, like, man, I am spending way too much money on blob services. Why? And turns out it's because I'm saving. I have 2 years of text file data that I don't need, don't use. It's just sitting there spending money. So I'm like, all right, I need to build a process to go back and clean up this blob storage. And I didn't want to write the code for it because writing Azure Blob Storage code is a pain in the butt. Well, let's see if there's a logic app that does this. This is my first major logic app. Every week on Sunday, I go and look at all the blobs inside of Blob Storage, and I will look to see when they were last modified. And if they were last modified more than, I think it's 30 days or 15 days, I don't remember what my cutoff is, I delete it. I have this delete blob method that just deletes the blob. This took me 5 minutes to write, and put in production, worked amazingly well. It costs 1 cent a month to run, or less than that, because it runs once a week and it takes all of 3 seconds to run when it's all done. So this is something that very well paid for itself immediately, because I didn't spend a lot of time on it, and it does its job fantastically. But thank you all so much for hanging out with me today. It's been a pleasure. And if you want to reach out to me afterwards, hit me up on Twitter, or go to my website, consultwithgriff.com. Also, don't forget to buy my course, SignalRMastery.com, if you're interested in real-time web development. But with that, thank you all so much. And I'll hang out for a second or two to answer questions, but I'm pretty sure we're all done here.